Determine if the following relationships are a function. So let's look at this first one, part C. The inputs are student IDs and the outputs are phone numbers. So we need to ask ourselves, are student IDs unique? Are phone numbers unique? Well, let's make up some students. So let's say student 1, 2, 3, 4, 5. We have student 4, 5, 6, 2, 5, 7, 1, 9, 82, 17. So these are students. And let's say these two students are siblings. And they live together. And now, by now, all of you probably have cell phones. Or might not even have landlines. But when I was a student, if you had a phone number, then your siblings all had the same phone number because you all shared that phone, that same landline. So here are the student IDs. And right here, I'm going to have phone numbers. So this phone number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That's the student's phone number. So that maps this way. These students have the same phone numbers. They have 1, 2, 3, 7, 8, 9, 4, 5, 6, 7. So they both go to this phone number. And then finally, this last student has phone number 1, 2, 3, 1, 2, 3, 4, 4, 4, 4. So if you notice, this is a function. We can have multiple students converging to the same phone number if they share, say, a phone. Now, of course, this first one is assuming no one has more than one number. So let's do this one again. What if we assume that students do have more than one phone number? What happens now? So now let's say we only have 3 students now, and this student has this phone number, but then this last student, has their landline, and they also have a cell phone number at 567 421 1234. Suddenly, is this a function? And again, this is assuming students can have more than one phone number. So in this first top case, when we assume that students only have one phone number, then this definitely was a function. But in this bottom case, if students are allowed to have more than one phone number, then this is not a function. Because this very last student here, we don't know if we input their student ID, we don't know what phone number would pop out. It could be their landline or their cell phone. And I purposely explained 2 different ways to look at this, since your answer can be correct if you explain and justify why. I can't just write function or not function and expect to say get full credit if I haven't explained my assumptions that I'm working with. All right, let's look at part D. And part D should be a little bit simpler because no matter what, everyone's only going to have one height. So let's start with our students again. And look, I'm back to having 4 students. And let's say this first student is 5 feet 5 inches. This next student is 6 feet 2 inches. This next student is also 6 feet 2 inches. And I'm going to make this arrow a little neater. There we go. And this last student is 4 feet 11 inches. So these are various heights that people can have, and everyone's going to have a unique height. So even though these 2 students share a height, each of them have exactly one height. So if for any reason I drew an arrow here and I wrote 5 feet 3 inches, these are very different heights. Someone can't be 4 feet 11 inches and 5 feet 3 inches simultaneously. You're one or the other. And high heels don't count. Your height is one or the other. That tells me that this is definitely a function no matter what.